Have you ever found yourself stuck trying to figure out how to make your C++ classes work together seamlessly? It can be a real puzzle, right? If that's you, then you're in the right place. Today, we're diving into a tricky question about retroactively defining a superclass in C++. I totally get it. You have a class that you can't modify, and you want to create a new class that behaves like a superclass for it. This is a common challenge for many developers, and it can feel frustrating when you hit a wall. Here's the specific situation we're looking at. One user recently asked, what's the closest thing in C++ to retroactively defining a superclass of a defined class? They provided an example with class A and class B, and they want to know how to make B act like a superclass of A without changing A. Sound familiar? Let's explore this together. So what's the issue here? In C++, you can't directly make a class a superclass of another class after it's been defined. However, there are some clever workarounds we can explore to achieve similar functionality. Let's break it down step by step. And stick around. I have a neat trick at the end that will help you understand how to manage class hierarchies in C++ more effectively. To achieve the desired functionality, the user can utilize a technique called type erasure. This allows the user to create a new class that can act as a bridge between class A and class B. Next, the user should define class B to inherit from a common interface or base class that both A and B can conform to. This will allow the user to treat instances of A as if they were instances of B. Now, the user can implement the methods in class B to call the corresponding methods in class A. This way, the user can ensure that the functionality of A is accessible through B. Finally, the user should ensure that their library can accept both A and B types. This can be done by using templates or polymorphism to handle both classes seamlessly. Fun fact, did you know that C++ was originally designed to add object-oriented features to the C programming language? It's fascinating how far it's come, but some challenges still remain. Now, let's look at the answers provided by other users. This user suggests using templates to achieve a similar effect. Instead of defining specific functions for class B, they recommend creating template functions that can work with any class that resembles B. This allows you to write generic code that can handle both class A and class B seamlessly. Additionally, the user shows how to create a template subclass that can inherit from any B-like class. This allows for extending functionality while still adhering to the B interface. That wraps up that answer. Let's move on to another one. This user suggests that while you can't change class A directly, you can create a new class D that inherits from both A and your desired superclasses B and C. This way, D can behave like A while also incorporating the functionality of B and C. Alternatively, you can use composition instead of inheritance. By including an instance of A within D, you can call A's methods without directly inheriting from it. This avoids potential confusion between different code bases. That's it for that response. Let's explore another one. This user suggests using static polymorphism through templates to achieve the desired functionality. They propose creating a template structure to check if a class has a specific member function, like bar. This allows you to use bar for any class without modifying the original classes. The user explains that this approach avoids vtable lookups, maintaining runtime efficiency. By using proper optimization flags, the indirection can be inlined, ensuring that invoking bar remains efficient. Here's the trick I promised. Always think about how you can leverage composition and templates in your designs. These tools can save you a lot of headaches when dealing with class hierarchies. And there you have it. You now have some strategies to work around the limitations of C++ class hierarchies. Remember, creativity in coding can lead to powerful solutions. If you found this helpful, hit that subscribe button for more tips. And don't miss our next video where we tackle another C++ challenge.